If A is 3 by 5 and B is 5 by 2, then B times A is defined. False, yeah. Because the inner dimensions have to match, but I switched the order, right? A times B could be defined because the 5s match, but when you switch it, the 2 and the 3 don't match, so this is false. Okay. In general, A times B equals B times A for two matrices. False. Matrix multiplication does not commute in general. You may be able to find an example where it does, but it's not a general rule. If A is an M by N matrix, then the what of A is N by M. No, it's not the inverse. The inverse of a matrix we'll talk about next class, but that's in general the same size as the original matrix A. Its inverse would be the same size. Nick, what do you have there? Transpose. The transpose. The transpose of a matrix switches the rows and the columns. Each row becomes a column, each column becomes a row. Transpose? No, I don't think so. You can still mark it right even if you were pronouncing it incorrectly. Okay, so this section 2.1 was basically about arithmetic on matrices. How do you add matrices? How do you multiply matrices? How do you find the transpose of a matrix? So I'm just going to do several examples, and then we'll be done. So this is really computational, no big concepts here. When you add matrices, you add them component-wise. So like the first row, column 1, row 1 gets added to column 1, row 1 from the other matrix, right? And when you multiply a matrix by a scalar, just like when you multiply a vector by a scalar, you just multiply every entry in the matrix by that number. So if I want to do A plus 2D, A is 2, 1, 0, negative 3, 0, 5, plus 2 times the matrix D means take every entry in D and multiply it by 2. So instead of 1, 1, 1, 1, 1, 1, it becomes 2, 2, 2, 2, 2, 2, which double everything. And then you add component-wise. Okay, so 2 plus 2 is 4. Negative 3 plus 2 is negative 1. 1 plus 2 is 3. 0 plus 2 is 2. 0 plus 2 is 2. And 5 plus 2 is 7. So that covers adding matrices and multiplying a matrix by a scalar. What about A plus B? You can't do it because if you were trying to add component-wise, right, they don't have the same components. So this one's impossible. To add two matrices, they have to have the exact same size. All right, A times B. So the matrix multiplication is going to be the trickiest computational piece, multiplying two matrices. It's very similar to multiplying a matrix times a vector, which we've been doing. We're just going to expand it a little bit. So there's two methods, your book's method. I believe they show you both methods, but there's one, they emphasize this first one. I kind of like the second one better, so we'll do it both ways. All right, so I want to do 2, 1, 0 times negative 3, 0, 5. Sorry, not times, that's the first matrix. Then times 1, negative 1, 2, 4. Okay. So your book says, do this like you would multiply a matrix times a vector. Ignore the 2, 4 for now. If I wanted to multiply this first matrix, 2, 1, 0, negative 3, 0, 5 times the vector 1, negative 1, you would take those two entries in the vector, the 1 and the negative 1. Each one would be a weight on your two columns, and then you'd add them together. So you do the same thing when you're multiplying a matrix times a matrix, except that what you get there is a vector, and it turns out that vector is the first column of the resulting matrix. So column 1 of your answer is going to be 2, 1, 0 with a weight of 1 on it, plus negative 3, 0, 5 with a weight of negative 1. So this is exactly how we learned how to multiply a matrix times a vector. take the entries in the vector as weights on the columns, add them together, and that's the result is a vector, and in this case it's a vector that is the first column of the answer matrix. So I end up with 5, 1, -5. So my answer, my first column is 5, 1, -5. Then I do this again. I take my whole first matrix A, and now I focus on the column 2, 4. So I multiply the whole first matrix by the 2, 4. So the column 2 of my result is going to be 2, 1, 0 times 2 plus -3, 0, 5 times 4. And so that's going to be 4 plus -12 is 8. 2, and then 0 plus 20. 20, I did something wrong, didn't I? -8. Yeah, -8. Thank you. So that's the second column of my answer matrix, -8 to 20. Does that make sense? Okay. So now the other method, I prefer it, but it's really, this is totally personal preference. You can do it whichever way you make sense to you. So here's another color. 2, 1, 0, -3, 0, 5 times 1, -1, 2, 4. All right, that first matrix, what are its dimensions? 3 by 2. And the second matrix is 2 by 2. So what's my answer matrix going to be? 3 by 2. Yeah, inner dimensions match, which means I am allowed to multiply them. The answer will be a 3 by 2 matrix. So I'm going to put sort of a blank 3 by 2 matrix to fill in here. A big 3 by 2. 3 rows, 2 columns. So I've got like 1, 2, 3 entries in 2 columns. All right, now I'm going to do the other method that we learned for multiplying a matrix times a vector. And when I take the dot product of each row times each column, you put it in the appropriate spot in the answer matrix. So for example, if I multiply the row 2, -3 by the column 1, -1, that's the first row of your matrix A times the first column of your matrix B, row 1, column 1, that goes in row 1, column 1 of your answer. So you're going to do 2 times 1. Imagine picking up this row, turn it 90 degrees, lay it on top of the first column, multiply the things that line up, and add the results. So we have 2 times 1 plus -3 times -1. Then you take that 2, -3, that row, and multiply it by the second column. So row 1 times column 2, and you're going to put the result in row 1, column 2 of your answer. So this is going to be 2 times 1 plus -3 times 4. Now we're done with row 1, right? I've multiplied 2, -3 times both columns of the second matrix, move to the next row. So you take row 2 times column 1, and you're going to put the result in row 2, column 1 of your answer. So I'm going to have 1 times 1 plus 0 times -1. Yes, thank you. Yeah, 2 times 2 plus -3 times 4. Thanks. Column 1B. Yep. Yeah, so it's all, you're always going to be multiplying rows of column 1. Sorry, rows of matrix 1, rows of matrix A times columns of matrix B. Row times column. Just like when you're doing a matrix times a vector. Row times column.
And then how do you decide which one it goes into?
The row number of matrix A and the column number of matrix B. So like I just did row 2 for matrix A times column 1 of matrix B. row 2, column 1, that's where you put it in the answer. So now I'm going to do row 2 times column 2, row 2 of matrix A times column 2 of matrix B. That's going to go in row 2, column 2 of the answer. So it's going to be 1 times 2 plus 0 times 4. And then you move to the third row, and you do the third row of column A times the third row of matrix A times each column of matrix B. So 0 times 1 plus 5 times negative 1, and then 0 times 2 plus 5 times 4, and then we do all the arithmetic, and our final result should be the same as what we got over here. So this is 2 plus 5, so sorry, 2 plus 3 is 5, 1 plus 0 is 1, 0 plus negative 5, and then 4 plus negative 12 is negative 8, 2, 20. So you can just pick your favorite method. I guess neither of these is better than the other. Questions on any of the steps in there? All right. B squared. In general, when you square something, that just means multiply it times itself. So that means take B, 1, negative 1, 2, 4, times 1, negative 1, 2, 4. And then use the rules for multiplication that we just learned. A transpose means make all the rows columns and columns rows. I'm not going to do this one out. So A is 2, 1, 0, negative 3, 0, 5. If I want to take the transpose of that and put a little T up top, means transpose. Each row becomes a column, each column becomes a row. So the dimensions are going to switch. And this is going to become 2, negative 3, 1, 0, 0, 5. So my 2, negative 3 was a row, now it's a column. My column of 2, 1, 0 was a column, now it's the first row. All right, B times D. So B is a 2 by 2. And D is a 3 by 2. So what about that?
Do it.
You can't do it. Yeah. That's why I left you no space to do it. Okay, and C times D, this is a 3 by 1. And D is a 3 by 2. Again, can't do it. The inner dimensions don't match. All right, so that is it for the lecture on matrix arithmetic. We're going to do the quiz now, and at the start of next class, I'll have you work through the activities for class 13.